This next chapter will be about securing the application the easiest and fastest way using the Spring Boot 2.2 security module. And this includes mainly the setting up of the Spring Security 5.2 framework, the creation of user details for the authentication process, applying the appropriate password encoding algorithm for the authentication, establishing the authorization rules for our application, and the implementation of some other details such as session management, URL rewriting, and other customized authentication processes. Other advanced topics will be also included in our discussion, such as the use of OpenID, Java Web Tokens, and Auth2 protocols. Let us now start with the core topic, which is protecting our Spring Boot 2.2 application with the Spring Security 5.2 framework. Now, Spring Boot 2.2 platform uses its Spring Security 5.2 starter module in providing the necessary authentication and authorization rules to our application. Now, this Spring Security 5.2 framework provides the necessary APIs in creating the security model that will implement the security protocol. Let us now figure out how to protect our applications using Spring Security 5.2. To utilize Spring Security 5.2 framework, we first need to include in our Gradle build the Spring Security 5.2 Spring Boot Starter module. And by registering this module means the automatic creation and setup of our delegating proxy filter class, which manages a filter chain of default authentication filters responsible for the creation of authentication processes. After this configuration, we proceed immediately to the creation of our configuration class, which inherits all the security-related methods from the framework's API, which is Web Security Configurer Adapter. The Web Security Configurer Adapter provides us essential methods in implementing the security model, and these methods include the Authentication Manager, User Detail Service, and these three configure overloads here, which are always present in Spring Security Core configuration. The configure with the local parameter Web Security helps us exclude all the global endpoints and static resources from the authentication processes, whereas the configure with the Authentication Manager Builder creates and builds the user detail and credentials, which will become part of the security context of the framework. For the meantime, we will be hard-coding our username and password without applying any password encoding algorithm. Thus, we will be inserting a no-op keyword enclosed in pair of curly braces before the password name. And we will be assigning a user role for this profile. And the most important configure overload is the one that has the HTTP security local parameter object. Now, this object provides us ant matchers that can help us identify which endpoints are to be authenticated. The HTTP Security API can also help us choose what authentication process we want to apply to our application. If we want to pursue basic authentication procedure, it has its HTTP basic method we can call anytime. If we want its built-in form login transaction, it has its form login method we can call alone. But if we want to establish a custom form login transactions, the HTTP security object can provide us all the methods necessary in order to build our form login and logout processes. If we want to choose the custom form login operations, after calling form login method here, we can just invoke the login page where we provide here the URL pattern of our login view. Afterwards, we immediately call the failure URL, which will ask for the login error page where all the unauthorized or invalid users will be redirected at. And by the way, the process of redirection will be managed by the default exception translation filter component of the framework. And after the failure URL, we call the default success URL, which will redirect the authorized user to the main page. Now, do not forget to invoke the permit all method after calling these three functional methods here. And for the logout operation, we need to provide the framework, our logout success URL page, which will be invoked after the user click the default logout endpoint of the framework. And for the meantime, we need to disable the CSRF component of the Spring Security Platform. And for the login logout web request implementation, I have here the login controller, which will render both the login and the login error page. The logout controller, which will be executed after clicking the default logout endpoint of the Spring Security, and the user's controller, which will render the main page of the application containing all the user profiles provided by the JPA profile repository class we have used in the previous section. And for this specimen, we will be using Thymeleaf templating engine as the Vue implementation. And before anything else, I need to emphasize that the logout link here, which is located in the main content page, must be using the default logout endpoint of Spring Security. And going back to Thymeleaf, since we will be using Thymeleaf templating engine, we need to also include a Thymeleaf Vue Resolver configuration class for our Vue implementation to work. There. After deploying our prototype, let's access now our main content page, but accessing it will redirect us to the login page. So we now use the hard-coded credential there. Clicking authenticate here will redirect us to the main page. And then when we click logout, it will redirect us to our logout success URL page. And it will be deleting all the session data and the session itself. Thus, clicking the back button here will just render us the login page without any memory of our main content page. And by the way, if we accidentally provide the login page with invalid credential, it will redirect to our login error page. We have just presented to you how to apply Spring Security Framework in our Spring Boot 2.2 project.